Welcome to G Fun Facts Online. Today we're talking about the invisible hand that's completely reshaping the video games you play every day. It's not a new graphics card or a faster processor. It's artificial intelligence. And this isn't science fiction about future games. A recent survey showed that a staggering 87% of game developers are already using AI agents in their work. AI is no longer just for creating cannon fodder enemies. It's the architect of living worlds, the author of adaptive stories, and the silent partner in your greatest gaming moments. So today, we're going on a journey from the simple blips of Pong to the hyper-realistic worlds of tomorrow to understand how AI agents are forging the future of video games. Let's start with a quick trip through time. The seeds of game AI were planted way back in the 1950s, with computers learning to play chess and checkers. But for most of us, the story begins in the arcades. In 1972, Pong gave us an AI opponent that was just a simple set of rules. If the ball is above me, move up. If it's below, move down. Rudimentary, but it worked. It created a competitor. Then, in 1978, Space Invaders changed the game. The alien horde didn't just move back and forth. They sped up as you defeated them. This simple trick created a rising sense of panic and tension that was incredibly effective. But the true genius of arcade-era AI arrived in 1980 with Pac-Man. Those four ghosts weren't just a colorful mob. They were a team, each with a distinct personality. Blinky, the red ghost, was the aggressor, programmed to chase you directly. Pinky, the pink ghost, was the clever one, trying to predict where you were going and cut you off. Inky was more unpredictable, and Clyde, the orange ghost, was the coward, chasing you but retreating if he got too close. This wasn't a random swarm. It was the illusion of a coordinated hunt, a landmark achievement for its time. As we moved into the 90s in the world of 3D, AI faced new challenges. Suddenly, characters needed to navigate complex 3D spaces, a problem we call pathfinding. And with the rise of real-time strategy games like Command & Conquer, AI had to manage resources, build bases, and command entire armies. This brings us to the modern era, where AI has moved from following simple scripts to displaying dynamic, emergent behavior. A huge leap came in 2005 with the first-person shooter FEAR. Its enemy AI was revolutionary. Enemies didn't just charge at you, they used tactics. They'd lay down suppressing fire, flank your position, and even communicate. It felt like you were fighting intelligent soldiers, not mindless drones. And in recent years, games like Red Dead Redemption 2 have taken AI to another level, using it not just for enemies, but to create an entire living world, where every single character has a life, a schedule, and memories of their interactions with you. This incredible evolution from a simple paddle to a living, breathing world happened because the technology behind the scenes was evolving just as fast. So what's actually going on under the hood? At its core, for any AI to function, it needs to solve two problems: where to go and what to do. The first problem, where to go, is solved by pathfinding algorithms. The most famous is called A-Star. You can think of A-Star as the AI's personal GPS. It calculates the most efficient route from point A to point B, avoiding walls, furniture, and other obstacles. It's the reason an enemy can chase you through a labyrinthine dungeon, or a friendly guide can lead you through a bustling city without getting stuck. The second problem, what to do, has been traditionally handled by something called a Finite State Machine, or FSM. An FSM is basically a simple flowchart. An AI character has a set number of states, like patrolling, attacking, fleeing, or reloading. It switches between these states based on simple triggers. For example, if patrolling and sees player, then switch to attacking. FSMs are simple and reliable, but they can get messy. For complex behaviors, you end up with a tangled web of states and transitions that programmers call spaghetti code, which is a nightmare to manage. To solve this, modern developers use behavior trees. Popularized by the groundbreaking AI in Halo 2, a behavior tree is a much more flexible and powerful tool. It's a hierarchical list of tasks. The AI checks tasks from top to bottom. For example, a tree might say, first, check if the enemy is in sight. If yes, check if my weapon has ammo. If yes, then shoot. If no ammo, then find cover and reload. If the enemy is not in sight, then patrol. This structure allows developers to build very complex and reactive behaviors from simple, reusable parts. It's much easier to design, debug, and expand. But the real revolution, the one happening right now, is machine learning. Instead of following pre-programmed rules from an FSM or a behavior tree, machine learning allows an AI to learn and adapt from data. The most exciting application of this is reinforcement learning. Here, an AI agent learns through pure trial and error. It tries an action, and if that action leads to a good outcome, like winning a fight, it gets a reward. If it leads to a bad outcome, it gets a penalty. Over thousands or millions of simulations, the AI learns a strategy to maximize its rewards. This is how AI has mastered incredibly complex games like Dota 2 and StarCraft 2 at a superhuman level. In the games you play, this could mean an enemy that learns your favorite tactics and develops counter-strategies specifically to beat you. The theory is fascinating, but let's look at some modern masterpieces to see this tech in action. We already mentioned FEAR from 2005, which still holds up as a masterclass in AI. Its enemies feel so smart because they use a system called Goal-Oriented Action Planning, or GOAP. Instead of a script, each soldier is given a goal, like kill the player, and a list of possible actions. The GOAP system lets the AI create a plan on the fly. If you take cover, the AI might decide the best plan is to have one soldier suppress you with fire, while another two flank you from the sides. This dynamic planning, combined with clever level design and audio cues of soldiers shouting, creates that terrifying illusion of a coordinated, thinking enemy. Another incredible example is Naughty Dog's The Last of Us. The AI here is all about emotional impact. The human enemies don't just feel like targets. They feel like desperate survivors. They exhibit self-preservation. They shout when you kill their friends, and they use the environment intelligently. But the real star is your companion, Ellie. Creating a partner AI that is helpful but not annoying is one of the hardest challenges in game design. Ellie's AI makes her feel like a capable, living person. She stays out of your way during stealth, helps you in combat, and makes comments about the world that feel natural and unscripted. She's not an escort mission, she's a partner. And then there's the monumental achievement of Red Dead Redemption 2. In this game, the AI's main purpose is to make the world itself breathe. Every non-player character, or NPC, in that vast world has a life. They have daily schedules, they go to work, they eat, they sleep, they remember you. If you help a stranger, they might greet you warmly the next time you see them in town. If you cause trouble, they'll remember that too. The wildlife has its own AI, creating a functioning ecosystem. A predator will hunt prey, scavengers will pick at carcasses. This creates a world that feels like it exists independently of you, a world you are merely visiting. It's a level of immersion created almost entirely by a complex web of interconnected AI systems. Of course, creating AI this advanced isn't easy. It presents a whole host of challenges. First, there's the cost. Building and testing these complex systems requires massive investment in time, money, and highly specialized talent. It's also a huge drain on processing power. Every bit of CPU a game uses for AI is a bit it can't use for graphics or physics, so developers are in a constant balancing act. Debugging is also a nightmare. When an AI learns and adapts, its behavior isn't always predictable, which can lead to bizarre, game-breaking bugs that are hard to replicate and fix. There's also the challenge of the fun factor. Sometimes, an AI can be too good. An AI that plays perfectly, that never misses a shot and exploits every mistake, isn't fun. It's just frustrating. Developers often have to intentionally program flaws into their AI, making them hesitate, make mistakes, or telegraph their attacks, all to give the human player a chance to win and feel good about it. Beyond these technical hurdles, there are significant ethical questions. AI systems learn from data, and if that data is biased, the AI will be biased too. This could lead to AI perpetuating harmful stereotypes in the characters it portrays or the worlds it generates. And as AI gets better at creating personalized experiences, there's a risk of it being used to design manipulative gameplay loops that pressure players into spending money or playing for unhealthy amounts of time. Finally, with generative AI now able to create art, code, and dialogue, there's a very real concern about job displacement within the games industry itself. These are complex issues with no easy answers, and the industry is actively grappling with how to move forward responsibly. So what does the future hold? We are standing on the brink of a new era. Generative AI is the term on everyone's lips. This is AI that doesn't just follow rules but creates new things. Imagine games with worlds that are not just built but are continuously generated and evolved by an AI, changing in response to the actions of millions of players. Think of AI-assisted asset creation, where developers can generate high-quality characters, environments, and textures almost instantly, dramatically speeding up development and allowing smaller teams to create massive, beautiful games. The NPCs of the future will be a game changer. Powered by the same large language models behind tools like ChatGPT, you'll be able to have real, unscripted conversations with characters. They'll remember your previous conversations, understand context, and have their own personalities and motivations. The quest giver won't just be a static icon on a map. They'll be a character you can truly interact with, persuade, or even deceive. This leads to the ultimate goal, a completely personalized experience. I will create adaptive narratives that shift and change based on your unique choices, making every playthrough truly different. It will dynamically adjust the difficulty to your skill level, ensuring you are always challenged but never overwhelmed. It could even learn what kind of missions you enjoy and generate more of that content for you. Technologies like cloud gaming and dedicated AI chips in next-gen consoles will provide the raw power needed to make these dreams a reality. We are moving towards a future where the line between a pre-scripted theme park and a living, simulated world becomes incredibly blurry. The games we play will be as unique, dynamic, and full of potential as we are. Thanks for tuning in to G Fun Facts Online. Well, see you next time.